So this episode we kind of want to pause, on just building stuff for now. Let's try to learn some things, right? So let's even see. Can we just learn some things? And yeah, for today, I just want to pick up this Tiger post. He dropped a post today, and I was like, yeah, this is quite interesting because most of what we've been dealing with, why you know building mainframe has to involve like buffers, involves streams. Maybe you might have seen some things that I've been doing, and you'll be wondering what in the world is going on here. How is this guy doing this? And maybe I did not really explain it that much. So we'll be going through this, and also I think I might learn some things from here too. So let's give it a try. So understanding HTTP responses and streams, everything you need to know to work effectively with responses and avoid surprises. So so there we go. We have this table of content. It looks like a pretty okay. It's not long. It's not a long article. So we have understanding response object. We have different ways to consume responses like the array buffer. In fact, I don't know about this that much too. I don't know about it much too. Then we have this, but yeah, these two they are usually used really well when you're dealing with streaming. So then you have streams, which can create your own readable streams. Yeah, we have all these different things. So let's go straight to the points. Understanding responsible objects. So sorry about that. Interesting. So a response object represents an HTTP response from a request. Yeah. So this should take us to MDN. I knew that. So the most basic way to create a response, this is how you create a response, and to show you that in action, we can pull up the terminal and just go into Node. So I'm going to increase this because I know there's a possibility you might not see the screen right now. So I'm going to put it on the other screen. So you might not be seeing the article, but I'll be reading it. So first of all, if you want to create a response, it's as simple as doing this, and then providing what response it is you want to return. So you have this response object available to you. In fact, I think one of the project ideas are in my head has to involve going barebone to Node.js. That's like if I'm going to do something like this after mainframe, where I'm maybe building a particular project, a personal project, it's going to be using barebone Node.js or maybe learning Bone. I don't know how to use Bone, so maybe I'll learn that. So, but it's going to be barebone. If I use Bond, though, Bond would have abstract some things away. Bond happens to be better. So when I say Bond, but I was actually saying referring to Deno. Those three of them, like the three of them, just sort of. So I was referring to Deno, not Bond. So you can create a new response this way, and once you do that, you can console log the response. Which once you do, this is what you get. You get the status, you get the status text, which we didn't provide anything like that. Then you get the headers. In this case, is plain and is a plain text. Then we get the body. Now, what do you notice in the body? You realize that in the body you get back a readable. So let me not go too forward. Like I'm just going to avoid that right now. So this is the same thing you get from fetch. If you are maybe using fetch API to make a request, before you use that .json, this is like what you get back usually. Well, yeah, this is something similar to what you get back. We are coming back to that. Let me just follow the article since we have to read the article, right? And so in this case, you can check for response.ok to be true in as much as the status is between 200 to 229. Sorry, I said 299 to be more. So an important concept is that response bodies can only be consumed once. So yeah, that's one important thing. And I think I even had this issue. There was a period I actually had the issue when I didn't know that was the case. So in that case, I ended up having to duplicate the response. I think normally they normally have this response.clone. I don't know. Let me see if yeah. So with this response.clone, you can create like a copy of that response, and you can use this copy to do something else. So most times, if you're going to consume the body of a particular response and you want to still preserve that body so that you can consume it, maybe you still want to preserve the body as a readable stream, you have to sort of clone it. So so yeah, there we go. And an important concept is this. And then sorry, I need to confirm if I'm still recording. It appears I'm still doing that, so good. So an important concept is this, and it can only be consumed once. So you have this stuff. So another thing you need to know is that you can also consume it this way, or you can consume it using text form. So for example, it depends on what type of response you are dealing with. So I can do something like this. I doubt I'll be allowed to use await here. Oh, I'm allowed. Nice. Oh, no JS. So I did something like that, and I'm getting back, the response stuff. If I try to do it again, text, it's going to fail. It's telling me that body is unusable, which means if I should log this out for you to see, body used is now set to true. So when I go back to the top here, you see that the body used was set to false, and for the readable stream on the body, lock was set to false. It was not yet locked, like we've not read it. But right now, log is set to true, and the state is now set to closed. So it's something you need to take note of. You can only read that body once. If you need to maybe read the body multiple times, you have to clone it. So okay, interesting. It was Tiger mentioned it here too. So if you need to read the body multiple times, use the clone method before the first consumption. So what that means is that you can simply just do clone. Okay, we've actually lost the body right now, so we need to redo what we did before. Okay, that actually failed. Okay, sorry. That was me doing some nonsense. So let me use this instead. Oh, I think if I do response equals this, because I know that in this console I can actually still initialize stuff again. Or am I thinking, or am I dreaming of something else? Oops, it seems I can't. Okay, in that case, so I create a rest guy, and then if I need to clone this, I can keep Python story. So I can keep a copy of this by just doing something like clone. Boom, that copy is kept. So if I do res clone, you will get this. If I do res, you will get this. So now if I read res by trying to convert it to JSON, which inadvertently fail. Uh, yeah, so let me use text, sorry. So, we've tried to read it the first time. You see, even if there was an error, in fact, I didn't know this before. Nice. So, if there was an error, the fact you've attempted to read it before, you can't read it again, even if there was an error in the process. So, you see, we get this error telling us that, okay, this thing is not a valid JSON, which is fine. So, but now, if we do rest this way, now log is true, state is closed, body is used. But if we go and use rest clone, it's still false. So, because we've cloned it. Most of the time you get response objects from fetch. Exactly. So if you have used fetch, you'll be familiar with all these things we are doing somehow because you would have seen it being used in fetch. Then fetch returns a response, a promise, like fetch gives you like a promise of a response. It's telling you, okay, I'm going to give you this response later. I'm promising you this response. I'll give you a response soon, right? That's what fetch does. Then you can check the status of the response. If it's okay, that means you don't have to read the body of the response yet. You can check it. You can also check the headers, like for different kind of things. For example, you want to check what the content type is. You can do all this. So yeah, at least with the content type, you can determine what you want to do with the stuff. If you know that, if for example you know that the content type is this, okay. If you know it is JSON, a lot of times you do no need to check the content type. But maybe you don't know, you can check the content type. So for example, there was a period I was trying to consume API that sometimes gives you error, and then the way it throws the error at you, it's usually in HTML, which is usually confusing. In that case, I used this to just avoid crashing the front end. So different ways to consume responses. We have seen this in action. Another way is the text, which I also demonstrated. The one way we've not talked about is the blob. And when you're using blob, you're using it for binary data, like images. So you're using it for binary data like images. So for example, let me just find an image online. In fact, I don't need to find an image online. I can find an image on my Dix. So I'm going to go to pictures and let's use this image of mine. Oops. So I'm going to copy the parts to this image, which interestingly, I think I can find it here. Okay. How do I get the parts? Interesting. So this is the name of the image, which is kind of good. So I'm going to do, so let me exit. Now I want to use fetch, right? So I'm going to do something like this. Await fetch, and I can paste that in like this. But remember, this is not the correct path, so it will throw me back an error. So the best thing to do is to copy this one too and paste it in the front. So here I can go this way and then press enter. Oh, we're getting a complaint that this is not a URL that could be passed. think I have, this should be in okay, give me a moment. Probably I'm naming it wrongly. Okay, path to URL, file URL. Yeah, that's what I was looking for. So good. That seems to work now. So here you can simply pass stuff this way. And then you get back a URL. So we can try to use this one. Let me see if this is going to work. So I'm going to save that in a file or in a variable, sorry. So I'm just going to call it URL. And then I can go back and use seriously, why do I keep making this mistake? So let me just exit. Seriously. Is this a joke? Okay, sorry about that. So I think we're getting a new error, fetch field. Interesting. So I'm getting this same error. Let me just go and find an image. Oh, I copied link address instead of image address. I was like, that image looks, that's the image address looks small. Better. So So you see that we get back a response. So yeah, some things might have look, some things may look different, but it's still a response we get back from fetch. So we get back this response, we get the status of the response, we get the text, in this case okay, we get a bunch of headers, and then we get the body, which is a string. So and then the URL. So we have this stuff, right? And let's see. So if you want to read because the data you're getting back is a binary, like, so if you want to read it, you could use blob, or you could use array buffer for raw binary data. In this case we are dealing with an image, so let's just use blob. So in that case I can do something like const. I don't want to be using const here, so let me just use blob. Let's blob, so I can easily just overwrite it anytime. What's it called again? Yeah, I want to clone it just in case. Clone, then blob, because it's a promise. Okay, we've already awaited it. I didn't even know when I wrote that. Weird. So I just created a blob guy, which you would see that once I run this, we get this stuff, and it's telling us the type is image JPEG. We can then go a step further. Note I'm following the article. I'm trying not to go out of line. So we can then go a step further and then say, okay, image URL should be URL dot create object URL from blob. So this should give us like a base64 URL. I think it's a base64, or how is it called? So we can pass that in. Oops, I use const for this one. So this is what we get back. Okay, it's not even a base64 URL, but it's a URL that contains that contains data of that blob. So if I go back to the browser and I open it up in the browser, I think, yeah, because of probably where we created it. So if I had created it in the browser, it would be stored in memory, and then if I try to open it on the browser, I would see it. But in this case, I can't really have access to it because of where I created it. So yeah, so what we did here when we create objects URL is that we basically take that the blob data, store it in memory, then just return back. That's so like a simple explanation of what happens. Then store it in memory and then return back like a URL for which we can use, like that we can use to access that particular object in memory. So if for example we did it on the browser and we try to kind of access it, so it means I could have even used the browser console to make it much more distinct for you to see, but then it means that you'll be able to kind of view it from the browser if you want to. So we also have the array buffer. How long is this thing getting? 23. Jeez. So we have the array buffer, which you can also do in that same manner. Basically you get back a buffer. This is like raw data, not like the blob. Blob is more for, you can at least that okay, this is information you get back, but this one is like a buffer, and as a buffer, clone array So when you do this gives you back an array buffer, which is basically the raw data. If you maybe have an algorithm, you can decide to now pass this buffer into the algorithm, and maybe it can do certain things to this data. So for example, you can try to figure out if this is an image from maybe the first set of few characters and stuff like that, or try to maybe grayscale the image and stuff like that. So yeah, this is the kind of buffer it needs to work with. Like this is the raw type of data it needs to work with in that case. And yeah, I think also, so we also have form data. That's if it's a form data actually, because I've not used this one before. To be candid, I've not used it before. So So this is like something new. I'm just also learning, and you see that in the headers, that it's set to application slash x www form URL encoded. So basically, which is this? It's quite interesting. Very interesting. I'm seeing like something possible, a possible stuff I can use it for. Sorry, I'm taking water at intervals. My throat happens to be scratching me right now. Key points about this method: each method returns a promise that resolves to the appropriate data type. Once you use any of this method, the response body is consumed. Choose the method based on the type of data you are expecting: JSON, text, blob, array, buffer, form data. What's binary data? Data in its raw form of ones and zeros. In fact, this one you are seeing here, it's actually in its raw form, but you are seeing it in this format because this is kind of encoded. So now everything in computers are of binary data: text, image, video are all binary data interpreted differently. Example: the letter A in binary is this, which is actually 65 in decimal. So what is ASCII? So this is like an encoding this. Okay, like I said, I'm not going fast. American Standard Code for Information Interchange. That's the full meaning of ASCII. That's if I can even remember. I don't know the full meaning of ASCII. I don't remember it. So ASCII is a character encoding standard where each letter or symbol maps to a number 0 to 127. So that's like the limit. Modern system mostly use UTF-8. You can learn about this. Like there is a lot of things to look into when you are dealing with these things. In fact, if you deal with text processing, most times you come across different encoding algorithms, or sorry, encoding schemes, and you just have to figure out. That's when I say encoding schemes, I'm referring to character encoding schemes. And then you just have to figure out, okay, how do you convert from this one to this? It's a tricky thing too. Then I think so for this one, const A is equal to 97, whereas this one is equal to 65. Basically, you just had. So basically, the idea is if you want to get small letter A, if you are using ASCII stuff, if you want to get small letter A, you just have to add 32 to capital letter A, because the capital letters come before the small letters. So, and in order to do that, you can to play around with this. You can use the text encoder class to play around with this. So so yeah, you can use the text encoder class to play around with this. I'm trying to remember the Python. There's two Python functions that you can also use to play around with stuff like this. That much easier in Python actually. So I'm back here again just to kind of show you what that looks like, and then I'm going to just create a text, set it to hello, and you might notice that way I did not put any keyword, maybe like const or let, because on the console I can actually do it this way. I think if I do it this way, I can actually rewrite it to something else. So it's like let. So there we go. I can just take this put it as an array. I'm following the article right now. So new text encoder, and then I've initialized a new text encoder, so I can now say, okay, encode this text, the text that I created above. So once I do this and I just do as array, so I'll get a u init 8 array. Basically it's still an array, but it's for binary data anyway. So in this case, you would see that it has been converted into like the UTF-8 encoding. So from what you can see, you see 104 for H. If in case you are wondering where H is 104, just think of it this way: capital A is 65, and H is basically, I think H is like 8 characters away from A. A, B, C, D, E, F, G, H. Yeah, 8 characters away from A. So if you add 8 to this, that means capital A should be something around 8 to this should be 73. So I should have 73, and then I can just say H plus 32, that is basically 73 plus 32, 73 plus 32, and that will give me 105. Yeah, I made one mistake, and that was because I was I fast forward by one. That was my mistake. So the time I said 73, I actually meant 72 because um, I started from 65. So I don't know if you get what I'm saying, but it's, if you try to replay what I just said, you get the error I made. So this is 104 for the first one. The other one. So these are all in UTF-8, and since we are using English characters, all these are also the equivalent in ASCII. So okay, let's just move on. What is array buffer? Array buffer is a raw binary data buffer, just bytes in memory. You can't manipulate array buffer directly, actually that's true. It's just raw memory. You need to use a view, and to use a view, that's where you see that u init 8 array coming. You need to use a view. A view is basically a way to read and write to the array buffer, and that view is what you can use to actually access it to manipulate data in the array buffer. Sorry, I want to drink water again. Okay, let's go. So this is what we have, like a unit take date. I don't know if I'm pronouncing this thing right, but a unit 8 array is a typed array that handles 8-bit unsigned integers. Please, if you don't know what an 8-bit unsigned or what unsigned integers are, just if I search for this, when you're unsigned, just assume that you are dealing with stuff that starts from 0, that's only positive. Okay, you can see in mathematics not having a plus or minus sign. So for these unsigned integers, they start from 0. There's no negative for this one, so if that makes sense. So just see it that way. That's like me. I'm trying to keep it simple. And each element is 8 bits. 8 bits is 1 byte, allowing values from 0 to 255. In case that confuses you, 1 bit is can only contain two different. Sorry, 1 bit can only contain 2 different. Sorry. Yeah, I think that should be the correct thing to say. Yeah, can only contain 2 different values. That was what I wanted to say. So if I raise this to the power of 8, because we are dealing with 8 bits, right? So if I raise this to the power of 8, I got 10. Sorry. So I got to 56. Wait, is this actually correct? This wait, that's like plus or something. That's plus. I don't know this operator exists as plus stuff, but yeah, this is it. 2 raised to the power 8 is 256. So basically, you are targeting that the values that you can have for each element in a unit 8 array is between 0 to 255, where 0 is representing the first character. So this is like what you have. So all these things you are seeing here, each of these elements, they are 8 bits in size, and they cannot go beyond 255. So to play further with this, we just got this one, right? So we have this as array. So let's try to see this in action. So I can copy this one. I'm following the article now. I wanted to actually play with this one that we've already created, but yeah, the article doesn't do that right now. So I'm just going to copy this one and create a new. And then paste it. So I have this A guy, and I can just do A0 to get the first one, similar to how you do with arrays, right? It's still an array. So Yeah, so another thing you can do is, sorry, I'm testing something. Okay, as expected. So so another thing you can do according to the article is you can create empty array using, you can create empty, like it's not really empty array, it's more like an array of zeros. That's a silly mistake on my side. So I can create it this way. So if I do empty, you will see that everything here is 0. Then so this is an example. Like I think currently it's just showing common ways you can create a unit array. Another thing you can do is to create it from normal array. So in this case you can do, so okay, we've actually done something like that before where we copied an array, this array, and then put it into this. So this is like creating it from a normal array. Another place you can create it from is from a buffer. So you can have const buffer, and I think we have a buffer above if I'm not mistaken. So yeah, we have a buffer guy up, so we can do, when I say buffer I'm referring to array buffer because you cannot just pass any buffer into it. It has to be an array. So now that I did this, if I have this from buffer, you see this is what we get back. Basically it's still the buffer, but now in this format. This is the view to access the buffer, meaning that with this buffer now I can just check each item in the buffer. So for example, I can do something like this, and there's item 255 in the buffer, which if I scroll up here we see ff is hexadecimal, and f is actually 15, so ff should give you 255 though. So yeah, and that each f you see there is basically a nibble. So if you have two nibbles make 8 bits, which make 1 byte. So okay, and next thing, you can't store values outside of this range. If you try to do that, it's going to sort of move it over the cycle. So what does that even mean? If I try to create, so if I try to create an array and I just create this guy, pass 256 to it, 256 is already beyond 255, pass -1, that shouldn't be there. Remember, it's supposed to be unsigned, and then pass 1.5, and it's, so 1.52 shouldn't be here because it's an integer. When I do this and I try to view it, you notice that -1 has become 255, 256 has become 0. Like I said, it goes over the cycle. So just assume you have like sorry about this. Should actually have loaded it because I've been here before. So assuming you have a circle like this where you have maybe you have 0 here, and then you have 255 here. So when you pass 256, it got here and then has to go back up again. Actually, this is incorrect to be candid, because 0 and 255 will be on the same spot. So they will sort of be on the same spot. So meaning not on the same spot exactly, more like very close. That means after 255, just like the clock. After 11 goes back to 12, goes back to 11, goes back to 12. So that's like the idea here. So once you get to 255, you're just going to continue down the clock plus 1, because that's what makes 256, and that becomes 0. Same thing with that 255, that minus 1 that we passed. When we pass minus 1, it goes back, and then it's 255. So that's like the idea there, and I think that makes what I was trying to explain. So there we go. Let me get back to this one. So where do we even use this unit 8 array? We use them in processing network requests, reading and writing files, working with streams, handling images or audio data. The reason they are befitting for such use cases the reason they are befitting for such use cases is because they are fixed size arrays of 8-bit units integers. Why 8 bits is good? Matches how data is commonly transmitted over networks, byte by bytes. 8 bits is 1 byte, remember. So most basic unit of data in computers is a byte. Streams. Now we have seen the response body is a readable stream. I think I've shown that before. This is the response body and it's a readable stream. I want to try to keep this at 1 hour max. So let's see. So yeah. So one thing you can do is you can sort of get reader this way. Let me see. I think I still have access to okay. Logged force. So yeah, I could do something like this. Reader and I could just take the response body and then get reader on it. So once I get reader, if I check the response, you would see that the response body is still logged is still set to true, and body has not yet been used, right? So this reader, I can now use something like, sorry, I'm still following the article in case you are wondering whether I've gone out of this thing. Sorry, Python, and this should be in brackets. So I can just say const done value awaits reader dot read. So this will give me the next chunk every time. So if done break. So and otherwise we can just console log value okay. I think it's actually ongoing, if I'm not mistaken. So there we go. Okay, good. So we can actually read the stuff like this, like basic stream reading. We can read it this way and then process the value as on the go this way. So a readable stream represents a source of data that you can read from piece by piece. Read operation returns an object with done and value. I think because it's probably an iterator. So then value is typically a unit 8 array chunk. Done becomes true when the stream is finished. So you can create your own readable, which is quite simple by just setting up a readable this way. And once you create your readable stream, so if you can create the stream, you can create it this way. So here you can say okay, starts, then you specify like the controller, then you can say the controller dot enqueue first chunk, enqueue second chunk. So there's one more thing you can do, which is to close the controller, which is basically like saying close the stream. So basically you just created a readable stream. You can see a readable stream here. You just created something like that. So we saw this supports BYOB to be set to 3. Your own case now it's not. Okay, so why streams? If streams didn't exist, you would have to load the entire file into memory, which becomes problematic. So instead of reading the entire buffer like us as a blob and then just put it on memory, especially if you are dealing with some video files which are usually large, and you can just stream it. So if you stream it, you can get chunk, like each chunk at a time. You can combine chunks together. One of the methods we've shown about doing that is using that getReader function. So I'm not missing anything. Okay, and let me see. Remember I said I want to stick to, so I guess the after on my plates. So another interesting thing you can do is to await this. You can use await off, right? Basically it behaves similarly to this, just that it's much more readable. At least if you see this, you know that okay, this reads better. So transform streams. Basically, transform streams are usually types of streams that you can modify the data as it passes through the stream, right? So, and you can create that also by just saying transport stream. It's already available to you. So there you can pass the transform method, passing the chunk, and then the controller. So we can have something like upper chunk, for example, chunk to so what do you notice from the transform stream? You have a readable and you have a writable, which is necessary. So you can then pipe through like the transform stream. So for example, because the response sent back to you is basically a response, right? And the body is a stream. You can do a lot of things with the body because the body is a stream. So for example, remember we made some requests for data here. So we have a body in set in what's the name of the so we can just say transformed should be equals to response dot body dot pipe dot pipe through, and then we can pass in the transport stream that we created. So when I press enter, we get back a readable stream because of course it's response.body. So what is handled for you? Back pressure management, internal queuing, stream locking, memory management, best practices. So we have all these different things. Some of the best practices to keep in mind. Include something like memory efficiency, which is download the entire file, rather load it in chunks. Ensure that you cancel a reader once you run into an error. So for example, when we use that, when the get reader stuff was used the other time, while we are reading, if there's any issue of any sort, you have to cancel the reader. Even if there's issue or there's no issue, you have to cancel the reader actually. So some of the issues that might occur when you're using the reader without canceling it is you can have resource leaks. So because the stream resources that was used by the reader, it remains open even if it's no longer being used and stuff. So you can also have like memory leaks too. So yeah, so memory that shouldn't be being used will be used. You can have network connections, which means the connection can stay open if it's a network stream. Another thing is other readers can't access. That means streams stay logged. No other reader can read from it. you can access it in the future. So a good pattern to undo this is this: you get the reader, then you try to you put the stuff in the dry block while you catch it and then do some finally stuff. At least whether it's successful or not, you want it to cancel. So you can do reader does cancel, and if it is successful, this is where all that will happen. So it will even get it here if that happens. So if it's not successful, it's the opposite. But both of them must call is. So another thing you have to notice, okay, common stream pipeline. Fetch, like when you're dealing with streams, most times you want to fetch the stream, you want to transfer it, then you want to process it before you save it. I said transfer, sorry, transform it. Fetching is easy. Sometimes the challenging part is usually the transforming and the processing. Some of the uses of streaming in general, what we've been saying about streaming so far include large file handling, real-time data, progressive loading, data transformation, and so on. So we have all these different things here, right? So, and I think that calls it a day or a video or an episode. So we stopped at 56. Okay, we still have like 4 minutes left. Well, enjoy your day, and I think I'll post this on LinkedIn very soon. So, yup, bye bye.